Hello. In this lesson, we're going to be covering some major ground. We're going to be talking about the three major types of rocks, igneous, metamorphic, and sedimentary rocks, which are three different lessons in a textbook. However, we're going to combine them all in one and just go over the edges of it so that you get a general idea as to what you're supposed to know. I would like for you to pay particular attention to the essential questions that are being asked. Those should be written down in your science journal, as well as all vocabulary words from each one of the three lessons. Each one of these three lessons will be divided for itself. So you will see igneous rock first, sedimentary rock second, and metamorphic rock last. Each one will have its own section. Each one will have its own key concept questions and vocabulary, excuse me, as well as any of the questions that I ask. Okay? So pay particular attention. Make sure you're stopping the video when you need to. Write the questions down in your science journal and your vocabulary words, writing the vocab and the definition when you find them. Each definition will be given to you. And at the end of each lesson, there will be a small amount of questions from that lesson that you will need to write. The rest of those we will work on in class together, but just be prepared. Okay, we're going to try to move through this fairly quickly. Okay, now I want to take a look at the picture that you're seeing, this one here and down in here. I want you to focus on this information here, the inquiry question. Can rock be liquid? The information that's there says the composition and temperature of lava influence whether it will be thick and pasty or thin and fluid, like water. How did this lava form? How did this lava that's here in this picture form? Well, the lava in this picture formed from a relatively thin and runny type of magma called mafic. Mafic is a type of magma. This lava will cool and harden to form a rock called basalt. Basalt is the black rock substance that you see all around where the magma has come down and hardened. Lavas that form from felsic magma are much thicker and do not flow as smoothly. So in this case, when you're taking a look at this picture, this one here, you can see that it's thin and runny. It's a thin and runny type of magma, which is called mafic magma. Okay? How did this lava form? I'm sure that you kind of have an idea. When it cools and crystallizes, what type of rock will it become? Think about crystallization. We talked about that with the rock cycle. And then the next one I want you to take a look at is this one. Where does this type of rock commonly form? Think of some places where that rock commonly forms. Okay? Now what I want to do is I want to come over here and pull up some questions that deal with this subject. Okay? You can pick one of these three questions to write in your science journal and answer. All right, pick one of those three. Where is lava in this photo coming from? That's this question here. The next one. What is the ropey looking substance that is forming on top of the lava? The ropey looking substance is what they're talking about here. If you kind of look in this areas, you can see what looks like ropes forming. That's what it's talking about right there. And it wants to know, what is the ropey looking substance that is forming on top of the lava? Okay, the last one you have to pick from is this one. Volcanic eruptions can vary from explosive to quiet. How would you characterize the eruption shown in this photo? Okay, so kind of go there and think about what they're talking about with those three questions. You were to pick one of those three, writing it in your science journal. Okay, one of those three. Okay, now we're going to be taking a look at some other things here, especially the essential question. How does igneous rock form? These questions get put in your science journal to where we can answer them by the end of the lesson. Okay, you should be able to answer these questions. That one, how does igneous rocks form? The other one doesn't look the same as it normally does, but this is the other essential question we need to answer. How are extrusive and intrusive rocks different? How are extrusive and intrusive rocks different? So this here and this here are your two essential questions. Please write them down in your science journal. We will be able to answer them by the end of the lesson. You also have 3 vocabulary words: extrusive, volcanic rock, try that again, volcanic glass, and intrusive rock. So extrusive rock, intrusive rock, and volcanic glass. Those 3 are your vocab words for this lesson. Go ahead and write those down in your science journal, and we will be answering those vocab definitions here in just a little bit.
Igneous rock formation. Do you remember what the difference is between magma and lava? Lava is magma that erupted onto Earth's surface during a volcanic eruption. When you hear the word lava, you might picture a hot, gooey liquid that flows easily. When lava cools and crystallizes, it becomes igneous rock. The lava shown in the picture on the previous page is already on its way to becoming solid igneous rock. It cools quickly after coming in contact with the cooler air around it. You can see where the lava has started to crystallize. It is the darker material on top of the red-hot molten material below. Not all magma makes it onto Earth's surface. Large volumes of magma cool and crystallize beneath Earth's surface. Under these conditions, cooling and crystallization takes a long time. The rock that results from subsurface cooling is different from the rock that results from lava cooling on Earth's surface. Over time, wind, rain, and other factors can wear away materials on Earth's surface. The rock that was once deep underground may now be exposed on Earth's surface. Stone Mountain, shown in Figure 7, is an example of igneous rock that formed from magma cooling slowly underground. Key concept check. How do igneous rocks form?
Okay, so Stone Mountain in Georgia is made of igneous rock that formed underground and are now exposed on Earth's surface. Okay, that would be this picture right here. All right, so the next thing I want to do is I want to take a couple of questions, one of them being a key concept question, and that would be these 2 here, this one and this one. And I want you to write those down in your science journal, both of them this time, please. What is the difference between magma and lava? This one would be a review question from our prior lesson of the rock cycle. So what is the difference between magma and lava? This one here, however, is a key concept question that we need to take a look at, and that is, how does igneous rocks form? All right, those 2 questions need to be written in your science journal and need to be answered, please.
Extrusive rocks. When volcanic material erupts and cools and crystallizes on Earth's surface, it forms a type of igneous rock called extrusive rock. Materials such as lava and ash solidify and form extrusive igneous rocks. Lava can cool rapidly on Earth's surface. This means that there might not be enough time for any crystals to grow. Extrusive igneous rocks, therefore, have fine-grained texture. Volcanic glass is rock that forms when lava cools too quickly to form crystals, such as the obsidian shown in Figure 8. Magma stored underground can contain dissolved gases. As magma moves toward the surface, pressure decreases, and the gases separate from the molten mixture. This is similar to the carbon dioxide that escapes when you open a carbonated beverage. When gas-rich lava erupts from a volcano, gases escape. Among the most noticeable features of some extrusive igneous rocks, such as pumice, are holes that are left after gas escapes, shown in Figure 8. Reading check. Why are there holes in some igneous rocks?
Okay, so let's talk about this extrusive rock. You have a couple of different things that I want you to make sure you're writing in your science journal, and that would be one of them right here, which is your definition of let's try this again. The definition of extrusive rock. When volcanic material erupts and cools and crystallizes on Earth's surface, it forms a type of igneous rock that is called extrusive rock. The next one I want you to write down in your science journal would be volcanic glass. Volcanic glass is rock that forms when lava cools too quickly to form crystals. Okay, so obsidian, this one right here in figure 8, is volcanic glass. All right, so those are two things. Pause this, write those definitions and those words, please. Okay, pause it and write. The texture of igneous rock is largely determined by the rate at which magma cools. When lava erupts on Earth's surface, it cools quickly, so mineral crystals don't have enough time to grow very large. However, the composition of magma can also affect the resulting texture of an igneous rock. You're going to be learning in this lesson here that the slower rate of cooling results in a network of larger, coarser crystals. Okay, so that is something we're going to have to understand, that the slower the magma cools, the larger the crystals or the grains will be in it. Okay, so next I want you to take a quick gander at these questions here. Okay, these questions here, you are going to pick one of those three questions. One of those three questions to answer. Okay, how does extrusive igneous rock form? Okay, the second one, why are there holes in some igneous rocks? And the third one here, why do extrusive igneous rocks have a fine-grained texture? So pick one of those three, pause this, write your question, and answer it from the information that we just talked about.
Intrusive rocks. Igneous rocks that form as magma cools underground are called intrusive rocks. Because magma within Earth is insulated by solid rock, it cools more slowly than lava on Earth's surface. When magma cools slowly, large, well-defined crystals form. Figure 9 shows a cross-section of Earth's crust where a magma chamber has solidified and formed intrusive rock. The arrangement of crystals in intrusive rocks is random. Crystals interlock like jigsaw puzzle pieces. A random arrangement and large crystals are typical of intrusive igneous rocks. Reading check. Where do intrusive rocks form?
Okay, so let's quickly take a look at this picture, this figure 9 here that was just referred to. Magma that cools and crystallizes beneath Earth's surface forms intrusive igneous rock. Lava or ash that erupts and cools on Earth's surface forms extrusive igneous rock. Okay, so the question I have for you is, where is magma cooling slowly? In this photo, in this photo here, where is magma cooling slowly? If you take a look right here, this right here, I would say that that would be where magma is cooling slowly. It's cooling slowly underground in the body right here. All right, now the next question I have is, where is lava cooling quickly? In this photo, where is lava cooling quickly? Remember, lava is above ground. So as we take a look at the photo, the magma comes up and hits the surface there where the liquid becomes lava. Okay, so if you notice right in here would be where the lava is cooling quickly. Okay, lava is cooling quickly here on the surface. I want you to note that molten rock that originates far underground and then cools will result in an intrusive igneous rock such as granite. And that would be this information here, intrusive, showing the granite. For your knowledge, the term intrusive or the word intrusive comes from Latin meaning to push in. Okay, to push in or intrude or intrusive.
Igneous rock identification. As you read in Lesson 1, two characteristics can help to identify all rocks: texture and composition. Geologists identify an igneous rock using the arrangement and size of mineral crystals in the rock. Chemical composition can also be used for igneous rock identification. Texture. Geologists determine whether an igneous rock is extrusive or intrusive by studying the rock's texture. If the crystals are small or impossible to see without a magnifying lens, the rock is extrusive. If all the crystals are large enough to see and have an interlocking texture, the rock is intrusive.
Okay, so scientists use texture to determine whether an igneous rock is intrusive or extrusive. Rocks made of large, interlocking crystals are intrusive, and rocks made of barely visible or microscopic crystals are extrusive. Okay, so what I want you to do at this point is I have 3 questions here. I would like for you to pick 2 of those 3 to write down in your science journal, please. 2 of 3. Which 2 characteristics do scientists use to classify igneous rock? What makes up an igneous rock's texture? How can geologists tell whether an igneous rock is extrusive or intrusive? Pick 2 of those 3. Okay, I also want to make sure that you have written down this vocab word, intrusive rock. Intrusive rock is igneous rock that form as magma cools underground. Okay, that vocab word needs to be in your science journal. So go ahead and pause it, write the word, write the definition, and be ready to move on.
Composition. In addition to texture, geologists study the mineral composition of igneous rocks. Igneous rocks are classified in part based on their silica content. Light-colored minerals such as quartz and feldspar contain greater amounts of silica. Dark-colored minerals such as olivine and pyroxene contain less silica and greater amounts of elements like magnesium and iron. If minerals are difficult to identify, you can sometimes estimate the composition by observing how dark in color the rock is. Lighter colored rocks are similar to granite in mineral composition. Darker colored rocks are similar to basalt in composition. Magma composition, the location where the lava or magma cools and crystallizes, and the cooling rate, determine the type of igneous rock that forms. For example, granite is high in silica, and it cooled slowly beneath Earth's surface. Granite is an intrusive igneous rock. Basalt is an extrusive igneous rock that has low silica content. It formed as lava rapidly cooled on Earth's surface.
So to give you a bit more information, the composition of rock depend on the types of minerals it's made of. The minerals that contain large portions of the elements iron and magnesium, such as pyroxene and olivine, are heavier and can be darker than minerals that contain higher portions of the element silicon, such as quartz and feldspar. The key concept question we had at the very beginning was, how are extrusive and intrusive igneous rocks different? Okay, so think about how that question can be answered. All right, because that is one of our important pieces of information, and we have come now to the end of this lesson, so you should be able to answer that. Okay, we will talk about those majors in class. Okay, make sure you have all the information written down that you need to, so that we can talk about it in class and get some additional information on questions you may have. All right, so we've come to our review of this lesson. Okay, I want you to do a couple of things for me. I know there's a lot of questions here, 1 through 9. However, you're not answering 1 through 9. I want you to answer question number 1, okay, number 2, number 4, number 6, and 7, okay, and I want you to draw number 9 and answer those circles, please. So that was 1 and 2, 4, 6, 7, and 9. Write those questions down in your science journal, answer them to the best of your knowledge, and we will go over those in class. Okay, the next rock we want to talk about is sedimentary rocks. We want to take a look at the photo that's right here, right, as well as the inquiry question. How did these broken rock fragments form? You'll notice the broken rock fragments they're talking about is right here in the picture. This river contributes to the formation of sedimentary rocks. The flowing water erodes rock and deposits broken fragments in the riverbed. Some of these rock fragments could have originated in the mountains above, this up here. What will happen to all this material? All this material they're talking about is this up here and all of this material here. What do you think will happen to all of that material? Although you might think that rivers affect rock only in the area immediately around them, they can affect the rocks in large areas. Over time, the course of rivers vary over a wide area, both eroding existing rock and depositing new sediment. So in the photo that we have here, the rock that's here will someday maybe not even be there. It will be downriver somewhere else. And the mountain that's here, the rock that's on the mountains, may end up down in here or somewhere else, broken into fragments and coming to a different location. Okay, so now let's take a look at some of the key information we need to write in our science journal. You'll want to make sure that you have these two key concept questions or essential questions written down. How do sedimentary rocks form? Okay, the other one is what are the three types of sedimentary rocks? Okay, this one is not as important as this one. How do sedimentary rocks form? It's quite important that we know this so that we know how the rock cycle really does work. Okay, the other thing you need to write down in your science journal is these vocabulary words: compaction, cementation, clastic rock, clast, chemical rock, and biochemical rock. All of those definitions will be given to you in this reading. So please make sure you have those words down, and when you see the definition, you pause the video and write the definition down as well, please. Okay? Now, asking you some important questions. Okay? What were these rock fragments once part of? I'm going to talk about what were these rock fragments. That's talking about these right here in the picture. What were they once part of? Okay, the next question is this one here. How did these rock fragments come to be lying in the stream bed? The third one, what will eventually happen to these rock fragments? Okay, I'd like for you to write down all three of those questions, please, and answer them to the best of your ability.
Sedimentary rock formation. Like igneous rocks, sedimentary rocks can form in different environments through a series of natural steps. Water and air can change the physical or chemical properties of rock. This change can cause rock to break apart, to dissolve, or to form new minerals. When water travels through rock, some of the elements in the rock can dissolve and be transported to new locations. Mineral and rock fragments can also be transported by water, glacial ice, gravity, or wind. The sediments eventually are deposited or laid down where they can then accumulate in layers. Imagine sediment deposits becoming thicker over time. Younger sediment layers bury older sediment layers. Eventually, the old and young layers of sediment can be buried by even younger sediment deposits. The weight from the layers of sediment forces out fluids and decreases the space between grains during a process called compaction. Compaction can lead to a process called cementation. When minerals dissolved in water crystallize between sediment grains, the process is called cementation. Mineral cement holds the grains together, as shown in Figure 10. Common minerals that cement sediment together include quartz, calcite, and clay. Key concept check. What is the difference between compaction and cementation?
Okay, as we look at Figure 10, that's this one here, after sediments are deposited, the process of compaction and cementation begin. So here's the deposition or depositing of those sediments. As they settle on top of each other, they start to compact or push the air out from where the holes are. After a while, Cementation happens because there is no air left between them. So now the pressure is pushing all of those rocks together, filling in all of the spaces. So compaction leads to cementation. Compaction is a process that squeezes particles together, as we see here. And cementation is a process that glues them in place. Glues them in place, that's seen here. Okay, so now I want you to take a look at the questions that I have for you. Okay, those all important questions. What are two ways that existing rock material can be transported to a new location? Another one, that would be this one. The second one is, what is the difference between compaction and cementation? Notice that it's one of our key questions that we need to answer. Okay, and another one is, which type of sedimentary rock would have a greater resistance to breaking down? One that forms by compaction only, or one that forms by both cementation and compaction? Okay, and it also asks you to explain. Here's what I would like for you to do. Choosing at least this question. I would like this question written down in your science journal, and you get to pick from this one or this one to also write down. So you're writing down two, but one of them has to include that one. Okay, that means pausing the video, writing the question down in your science journal, and then answering those questions. Okay? Okay, so now we also need to remember that we have vocab words that we need to make sure we're writing down. So, compaction. Compaction. So please write definition for compaction. The weight from the layers of sediment forces out fluid and decreases the space between grains during a process called compaction. So compaction is a process. Compaction. Pause the video. Make sure that you are writing that definition down, please. Also, want you to make sure that you know the next one, which is this one. Okay? Cementation. When minerals dissolve in water crystallize between sediment grains, the process is called cementation. Make sure you have those two vocab words and definitions written down in your science journal, please.
Sedimentary rock identification. Like igneous rocks, sedimentary rocks are classified according to how they form. Sedimentary rocks form when sediments, rock fragments, minerals, or organic materials are deposited, compacted, and then cemented together. They also form during evaporation, when minerals crystallize from water or when organisms remove minerals from the water to make their shells or skeletons.
Okay, so from that information, I want to pull this piece of information out. Okay, you are to pick one of these two questions to write down in your science journal and answer. In which way are both igneous and sedimentary rocks classified? And then the second one would be, briefly describe two ways in which sedimentary rocks can form.
Clastic sedimentary rocks. Some rocks, such as sandstone, have a gritty texture that is similar to sugar. Sandstone is a common clastic sedimentary rock. Sedimentary rocks that are made up of broken pieces of minerals and rock fragments are known as clastic rocks. The broken pieces and fragments are called clasts. Geologists identify clastic rocks according to clast size and shape. The conglomerate in Figure 11 is an example of a rock that was deposited in a river channel. The large sediment pieces were polished and rounded as they bounced along the bottom of the channel. However, the angular fragments in the breccia in Figure 11 probably weren't transported far because their sharp edges were not worn away. Sediment size alone cannot be used to determine the environment where a clastic rock formed. For example, sediment deposited by a glacier can be the size of a car or as small as grains of flour. That's because ice can move both large and small clasts. Geologists study the shape of clasts to help determine the environment where a rock formed. For example, a fast-flowing river and ocean waves tend to move large sediment. Small, gritty sediment is typically deposited in calm environments, such as the seafloor or the bottom of a lake. Reading check. Why can't sediment size alone be used to identify a sedimentary rock environment?
Okay, want to clarify something in your mind. When we talk about sediment, you may think about small little pieces of rock that's been broken off. You probably think of them as sizes of like quarters or dimes or nickels or pennies. However, those sizes can vary. The sizes of sediment can vary. Sediment moved by glaciers can be as big as a house or as small and fine as flour. This needs to be clarified in your head because each one comes from a larger item. All right, so glaciers can carry big pieces of sediment as large as a house or as fine as flour. Clarify that in your head, okay? Next thing I want to do, I want you to write your definitions. There are two of them. One is clastic. Clastic is sedimentary rock that are made up of broken pieces of minerals and rock fragments, okay? The second one is clast, the broken pieces and fragments. The broken pieces and fragments are called clast, okay? So make sure you're writing these two definitions down in your science journal, please. Okay, next thing I want you to do, I want you to pick one of these three. One of these three. Okay? What are classed? Okay, that's one of them. That's this one here. The second one, why can't sediment size alone be used to identify a sedimentary rock environment? That's this one here. The next one, take a look at the clasts that make up each rock in Figure 11. Figure 11 is this here. Could the clast in each have come from any type of rock? Explain. Okay, so you pick one of those three, please. Pick one of those three and write the question and the answer. All right, and we'll be discussing those in class.
Chemical sedimentary rocks. Remember that as water flows through cracks or empty spaces in rock, it can dissolve minerals in the rock. Eventually, rivers carry these dissolved minerals to the oceans. Dissolved minerals entering the ocean contribute to the saltiness of seawater. Water can become saturated with dissolved minerals. When this occurs, particles can crystallize out of the water and form minerals as shown in Figure 12. Chemical rocks form when minerals crystallize directly from water. Rock salt, rock gypsum, and limestone are examples of common chemical sedimentary rocks. Reading check. How do chemical rocks form? Chemical sedimentary rocks often have an interlocking crystalline texture, similar to the textures of many igneous rocks. One difference between intrusive igneous rocks and chemical sedimentary rocks is that igneous rocks are composed of a variety of minerals, and they appear multicolored. Chemical sedimentary rocks are generally composed of one dominant mineral and are uniform in color. For example, granite is made of quartz, feldspar, and mica, but rock salt is composed only of the mineral halite.
Compared to the formation of clastic sedimentary rocks, the formation of chemical sedimentary rocks can be harder to visualize. I encourage you to think about chemical processes such as evaporation, which you have observed and experienced, and apply that to the understanding of how chemical sedimentary rocks form. Okay, so the next thing I want to do is I want to give you your wonderful questions. So you get to pick 1, 2, 3. You get to pick one of those three. Okay, one of those three questions to write the answer and to write the question and the answer in your science journal. What can happen to a rock when water flows through cracks or holes in the rock? The second one would be, how do chemical rocks form? And the third one is this one here. Why do you think that unlike igneous rocks, chemical sedimentary rocks are usually made up of only one mineral? Again, you're writing one of those three questions in your science journal and you're answering it. Also, you need to make sure that you have this written down, which is your vocab word. Chemical rocks form when minerals crystallize directly from water. Make sure you have that written down in your science journal as one of your definitions.
Biochemical sedimentary rocks. Biochemical rock is a sedimentary rock that was formed by organisms or contains the remains of organisms. The most common biochemical sedimentary rock is limestone. Marine organisms make their hard parts from dissolved minerals in the ocean. When these organisms die, their hard parts settle onto the sea floor. This sediment is compacted and cemented and forms limestone. Sometimes the remains or traces of these organisms are preserved as fossils in sedimentary rock. Geologists call limestone that contains fossils fossiliferous limestone, shown in Table 2. Limestone is classified as a type of carbonate rock because it contains the elements carbon and oxygen. Carbonate rocks will fizz in presence of hydrochloric acid. Geologists use this chemical property to help identify different varieties of limestone. Not all biochemical sedimentary rocks are carbonates. Some microscopic ocean organisms make their shells by removing silicon and oxygen from seawater. When these organisms die and settle on the ocean floor, compaction and cementation turns this sediment into the sedimentary rock chert. Coal is another type of biochemical sedimentary rock. It is composed of the remains of plants and animals from prehistoric swamps. Over time, these organic remains were buried. Burial led to compression, which eventually changed the remains into a sedimentary rock. Key concept check. How do chemical and biochemical sedimentary rocks form?
Okay, so let's take a look at this chart. I want to ask a couple of questions because I noticed a couple of things that were pointing out to me when I saw the chart, and that's limestone. Notice how it appears twice on this diagram, on this table. Explain why limestone appears in two different places on the chart. Why do you think limestone appears in two different places on the chart? Notice something else about that same thing, and the mineral composition of chemical limestone is calcite, and that the mineral composition of fossiliferous, boy that's a mouthful, fossiliferous limestone is also calcite. However, the type, notice the type, is chemical and biochemical. So how is it possible for limestone to be on each one of those and to show up on the chart twice? So have you thought about it for a second? You should state, when you think about this, you should state that the limestone can form as either a chemical rock made of calcite or a biochemical rock made of fossils that are in turn made of calcite also. Okay, so I have another question for you. Does the rock coal contain any minerals? Okay, does the rock coal, which is here, that's the rock name, does it contain any minerals? Notice mineral composition is carbon. Okay? But then I want you to take a look at an identifying factor, which are those two little marks there. Can you find anything on this chart that helps you to get additional information about carbon in coal? Do you see it yet? You want a little hint? Look down here at the bottom. Right here will tell you, see the two little marks? Two little marks are the same as those. It tells you that carbon in coal is not a mineral. So to answer the question, it is not a mineral. It has no minerals in it because of the footnote at the bottom. It's telling you that. Okay, so have a couple of things for you. One, make sure you're writing your definition. Biochemical rock is sedimentary rock that was formed by organisms or contains the remains of organisms. Okay, so make sure you have that definition in your science journal, please. And the next thing I want you to do is this. You're picking one of the three. One of the three. How is biochemical sedimentary rock different from chemical sedimentary rock? The second one, how do chemical and biochemical sedimentary rocks form? And the last one, imagine you have two rock samples and know that one is chert and the other is limestone. How could you tell which sample is which? So you're picking one of those three, please. Writing in your science journal and answering them. Okay, so our review is here for sedimentary rock. I want you to answer not all of the questions, but some of them, okay? And I want you to do question 1, question 2, question 4, question 6, question 8, okay? Those questions, 1, 2, 4, 6, and 8. Answer those in your science journal, please, using the information that you have. And we will go through the rest of them, those and the rest of them in class. Okay, this section is the last of the three with metamorphic rock. I want to make sure that you take a look at these two questions. How do metamorphic rocks form? That is the main one. And how do types of metamorphic rock differ? These two questions are our essential questions. Also want you to pay particular attention to the key terms or the vocabulary words, since you will be having a vocabulary test over these terms. Metamorphism, plastic deformation, foliated rock, non-foliated rock, contact metamorphism, and regional metamorphism. Okay, those are the terms. Make sure you have them written down in your science journal, please. And as we go through this lesson, make sure you're writing down the definitions for those terms. Okay, so now I want to look at the photo that's here, okay, as well as the inquiry question. How did this wrinkle? Sediment is usually deposited in horizontal layers. Horizontal means it goes side to side. Okay? Under the right conditions, however, those layers can be bent and twisted. Imagine the incredible amount of pressure required to cause solid rocks such as this to bend. Imagine that. Metamorphism can happen in rocks in different ways. This photo shows layers of rocks that were originally horizontal, as we talked about. Horizontal being side to side. They have been bent and folded by immense pressure over a long period of time. Even solid rock can behave in a plastic manner or behave like plastic. Given enough time and the right amount of force, those rocks can be bent just like the ones in the picture. So imagine the amount of force that it's taken to do that. Okay? Make sure that you think about that picture because this is the direction we're going, which force and heat is a part of this. Okay? Next thing I want to do, I want to bring forward your 3 questions. You are to make sure that you're answering all 3 of these questions in your science journal. You're writing them, and putting your answer down, please. So that means you get to pause the video, write your questions and answers, and then start the video back up again. So the first question, What other type of materials have you seen or used that could be bent and folded in this way? Okay. What type of rock do you think this was before it became metamorphosed? Okay. What type of rock do you think this was before it changed? And the third one, imagine that you have a machine that could apply enough force to a rock layer to change its shape. Do you think you could use it to bend the layer in a way similar to this in the photo? Explain. Okay, so you're to write all of 3 of those questions, please. I know that's a lot of writing, especially with this one, but please do it because you won't have to write all the questions throughout the text, which is what you have noticed. We've kind of switched some things up. Okay, so please, all 3 questions, answer all 3.
Metamorphic rock formation. Imagine you left a cheese sandwich in your backpack on a hot day and then threw your backpack into your locker. Would the sandwich look the same after school? Changes in the temperature during the day would likely cause the cheese to soften. Pressure from the weight of your backpack would squish the sandwich. Like the sandwich, rocks are also affected by changes in temperatures and pressure. These rocks are called metamorphic rocks. Metamorphism is any process that affects the structure or composition of a rock in a solid state as a result of changes in temperature, pressure, or the addition of chemical fluids. Most metamorphic rocks form deep within Earth's crust. Like igneous rocks, metamorphic rocks form under high temperature and pressure conditions. But unlike igneous rocks, metamorphic rocks do not crystallize from magma. Unlike sedimentary rocks, metamorphic rocks do not result from erosion and deposition. The metamorphic rocks shown on the facing page have changed shape. Exposed to extreme temperatures and pressure, the rocks were bent and twisted into wrinkly layers and are classified as metamorphic rocks. Reading check. What is metamorphism?
Okay, so what is metamorphism? That's where we're going right now. You'll notice your first definition. You need to write that definition down in your science journal, please. And make sure that you have all of that in there. You may pause the video so that you can write and then restart it. Metamorphism is the process that affects the structure or composition of a rock in a solid state as a result of changes in temperature, pressure, or the addition of chemical fluids. Okay, so that is your definition.
Temperature and pressure. When rocks experience an increase in temperature and pressure, they behave like a bendable plastic. Without melting, the rocks bend or fold. This permanent change in shape by bending and folding is called plastic deformation. It's one way the texture of a rock changes during metamorphism. Plastic deformation occurs during uplift events when tectonic plates collide and form mountains, such as the Himalayas in Asia. Changes in composition and structure are clues that a rock has been metamorphosed. The rock that changes during metamorphism is called the parent rock. The temperatures required to metamorphose rock depend on the parent rock's composition. The lower limit of the temperature range for metamorphic rock formation is between 150 degrees Celsius and 200 degrees Celsius. In addition to temperature, pressure also increases with depth in Earth's crust and mantle, as shown in Figure 13. Pressure is measured in kilobars, kb. Key concept: under what conditions do metamorphic rocks form?
Okay, so if you noticed, I pointed out your vocab word. So please write that vocabulary word, plastic deformation, and its definition: this permanent change in shape by bending and folding. Okay, permanent shape change by bending and folding. All right, make sure you have that down. Okay, I put this chart here so that you can see this figure 13. Pressure increases with depth of earth. So here's your pressure. Okay, pressure increases with the depth. So as you go deeper into the ground, the pressure increases, which is why the line looks like this. Like sedimentary rocks, Metamorphic rocks can form when material is subjected to increased temperature and pressure. However, to form a metamorphic rock, the temperature and pressure must be high enough to change the structure of the minerals without causing them to melt. I need to remind you that pressure is measured in bars, and 1 kb is equal to 1,000 bars. So in this diagram, okay, 4 kb, 4 kb, which is that right there, is equal to 4,000 bars. All right. Now, what I want you to do, of course, I have questions. Questions. Okay, you are to pick one. Actually, you're to pick one other one besides this one. Under what conditions do metamorphic rocks form? You need to write that one, and you need to pick one of the other two. How does plastic deformation affect rock formation? That would be that one, or this one here. Why does the temperature at which metamorphism can occur depend in part on the composition of the parent rock? Okay, so make sure you're picking one of these two and this one, writing them in your science journal and answering them, please.
Metamorphic rock identification. Changes in temperature, pressure, or the addition of chemical fluids can result in the rearrangement of minerals or the formation of new minerals in a metamorphic rock. Geologists study the texture and composition of minerals to identify metamorphic rocks. Metamorphic rocks are classified into two groups based on texture. In many cases, changes in pressure cause minerals to align and form layers in metamorphic rocks. This layering can appear similar to the layers associated with clastic sedimentary rocks. However, the crystalline minerals present in a metamorphic rock distinguish it from a clastic sedimentary rock. In other cases, the rock can have blocky, interlocking crystals that appear uniform in color.
Okay, remember that metamorphic rock, like igneous and sedimentary rock, are classified according to their composition and texture. The texture of metamorphic rocks helps us learn about how the rock was formed. You need to learn about the two types of texture in metamorphic rock that depend on the degree of heat and temperature. That's what we're going to be talking about. Okay, so now, like always, I'm going to be giving you some more questions. You get to pick one of the two to write in your science journal and answer. Okay, one of the two. Can new minerals form in a rock that is undergoing metamorphosis? Explain. And how are the layers in metamorphic rock different from layers in sedimentary rock? You choose the two. You choose one of those two to answer in your science journal, please. Okay. Now, I'm going to bring this back up. All right, because we're going to be using it with this information over here, and that is learning about graphs. If you notice, it says the line graph in figure 13 represents pressure below Earth's surface. It asks, what is the pressure at a depth of 50 kilometers? These are measured for the depth in kilometers. Okay, so what it says to do, you're following the instructions A, B, and C. Okay, you are going to take a look over here and see if you can find 50 kilometers. That's pretty easy since it's already marked. 50 kilometers. You're going to read the title of the graph to determine what data is represented. Pressure versus depth. All right. Read the labels on the X and the Y axis to determine the units. Here's pressure, and over on the other side is depth. Okay, and it says move horizontally from 50 kilometers to the orange line. Okay, so we're finding 50 kilometers and we're moving horizontally. We're going this direction to the orange line. Okay, once we're on the orange line, move vertically from the orange line to the x-axis. The x-axis would be down here. Now, as you notice, we are not on a line, so we have to estimate between this one and this one. So roughly, the pressure is 14 kb. Okay? Okay, so at what depth is the pressure 20? So let's go ahead. Here's your pressure going up. Okay, got the orange line going over. And it looks like it is what? 70 kilometers. Okay, so that's how you're reading this chart. That's how you're reading that chart.
Foliated rocks. The metamorphic rock schist, shown in Figure 14, is an example of a foliated rock. Foliated rocks contain parallel layers of flat and elongated minerals. Look closely at the layers of dark and light minerals in the schist. This layering results from an uneven distribution of pressure during metamorphism. Foliation is a common feature in metamorphic rocks. Reading check. What type of metamorphic rock has layers?
Okay, so let me go ahead and make that a little bit smaller and make sure that I have your vocab word up here, which is foliated rocks. Foliated rocks contain parallel layers of flat and elongated material or minerals. That's what they're talking about here. You can kind of see in this rock, sorry, I'll go like this a little bigger. You can kind of see the layers in this rock here. Which means that the pressure, if you look at the visual check, can you determine the direction that the pressure was applied? The pressure was applied going this direction, which is down, okay, going down, so that these lines were to form, kind of like a pancake. Okay, so make sure you have your vocab word and definition written in your science journal, please.
Non-foliated rocks. Metamorphic rocks that have mineral grains with a random interlocking texture are non-foliated rocks. There is no obvious alignment of the mineral crystals in a non-foliated metamorphic rock. Instead, the individual crystals are blocky and approximately equal in size. This crystalline texture differs from an igneous rock in that the minerals are generally uniform in color, as opposed to multicolored, as in igneous rocks such as granite.
Okay, so you'll notice that I have your information right here for non-foliated rock. Please make sure you're writing that in your science journal, so that means pausing and writing your definition and your word, please. Okay, non-foliated rocks are metamorphic rocks that have mineral grains with a random interlocking texture. All right, so make sure you have that one written down. Next thing on my list to do is to pull this information out, and you pick one of the two. One of the two questions to answer. How are non-foliated metamorphic rocks different from foliated metamorphic rocks? Or you can pick this one. How can you tell the difference between non-foliated metamorphic rocks and an intrusive igneous rock? One of those two, please. Write the information and the answer, please. All right.
Contact and regional metamorphism. One way a non-foliated metamorphic rock can form is when magma intrudes rock. During contact metamorphism, magma comes in contact with existing rock, and its thermal energy and gases interact with the surrounding rock and forms new metamorphic rock. Contact metamorphism can increase crystal size or form new minerals and change rock. A common example of a non-foliated rock, marble, is shown in Figure 15. Notice the uniform color and crystal size in this specimen. Table 3 illustrates other examples of non-foliated and foliated metamorphic rocks. Regional metamorphism is the formation of metamorphic rock bodies that are hundreds of square kilometers in size. This process can create an entire mountain range of metamorphic rock. Changes in temperature and pressure and the presence of chemical fluids act on large volumes of rock and produce metamorphic textures. These textures can help unravel the mysteries of a mountain-building event. The Himalayas in Asia and the Appalachian Mountains of the eastern United States exhibit structures associated with regional metamorphism. Key concept check. Compare and contrast contact metamorphism and regional metamorphism.
Okay, you'll notice that I have put a couple of things in here. Here's one, and here's one. Contact metamorphism. Okay, make sure that you write its definition. And basically, it is information that says during contact metamorphism, magma comes in contact with existing rock, and its thermal energy and gases interact with the surrounding rock and forms new metamorphic rock. Okay, that's contact. Regional. Regional metamorphism is the formation of metamorphic rock bodies that are hundreds of square kilometers in size. Okay, those two, please make sure you're writing your information down. Okay, so hoping you've written those down. Next thing we're doing is kind of looking very quickly at this table 3 of the metamorphic rocks. You'll see texture, composition, rock name, and an example. The examples are a little dark. I apologize, couldn't get them any better than that. But what I want to make sure you notice is texture. Foliated and non-foliated. Remember again that we're looking at both texture and composition to determine what type of rock is. Okay? Foliated and non-foliated is very important. What comes inside of it, quartz or calcite, feldspar, some of the same ones that we've seen in the past. That is the composition, that's what it's made up of, so that we can tell where that rock was composed. Okay? Next thing on my list. Go ahead and pick, especially this one, okay? But then you get to choose one of the other two. Okay, you get to choose which one you would want to talk about or which one you want to write in your science journal and answer that question. The first one, which are the two criteria that are used to classify all 3 major rock types? The second one, make sure you're writing that one, compare and contrast. Remember, comparing is similarities, contrasting is the difference. Contact metamorphism and regional metamorphism. Compare and contrast them. Okay, and the last one you have to pick from would be this one. Why doesn't contact metamorphism occur over large areas the way regional metamorphism does? Okay, so you're picking this one for a fact, and this one or this one, whichever one you want to choose. Okay? Okay, and so with all of that information that I've just given you, we've come to the end of this lesson. Okay? The information that you see in front of you right now is on metamorphism. So again, like the others, you're not doing all of them, just some of them. I would like for you to do question number 1, question 2 and 3, question 4, question 6, and I also want you to do the mathematics question, which is question 8. Okay? Question 1, 2, and 3, and 4. Okay, 1, 2, 3, and 4. Question 6 and question 8. Make sure you're putting all of that in your science journal so we can go through it. We will talk about it, and we will see whether or not you know the information. I hope with all of this information you will be able to determine the type of rock you're looking at now, whether it be igneous, sedimentary, or metamorphic. And I hope you got some information out of this that you didn't know in the past. Thanks, and I hope you have a great day.